Welcome, students. So this is our first question from the assignment from May 18th. We're just going to go through some AP final exam questions. This one happened to be from chapter 4, which was probability. I wanted to review. So what we have is a fair spinner. Okay, so what they're saying here is that all the slices are pretty much equal, same area. So what I did was just counted up all the different types. And what we have is 6 zeros, 3 $1 payouts, and one $10 payout. Okay. So go ahead and read that and make sure that you're following. Basically, then what they're looking at is for the probability. Okay. So it's 10 equal spaces, so each space has a 0.1. There's 6 of those, so you should get 0.6 there. There's 3, so the count for this is there's 6 of them. There's 3 of these and there's 1 of these. This should be 0.30 and this should be 0.10. Okay, now expected value of the net contribution. There is a formula on your formula sheet that they're going to expect you to use. Okay, so it should be this one, possibly. Okay, so they're going to use this summation symbol. Let's see, I think it's going to be something like x sub I times p of x sub I. So it's going to be the amount times the probability of that amount all added together. The summation symbol is add every term together. Okay. Now, you have to show your mechanics to get full credit. Okay. We can't just tell what the computer output is. So they're expecting this. Okay. The first outcome is a $2 payout. Or sorry, for the charity is actually $2. The person's losing $2. It's playing, so but the charity's getting $2. Okay, so for the $1, that's going to happen 0.3, and for a loss of 8. So once in a while they're going to have to pay out. So it's a loss of 8. Okay, now you can just let the calculator do that, and it seems like it's going to be 0.7. Now that is for one single event. Even though you can't get 70 cents, the charity can never get 70 cents from one single trial of this. But in the long run, they're going to average 70 cents per spin. Okay, that's the idea of this expected value. In the long run, what can you expect? Okay, so now the charity, this is, that would be, is A really that easy? Okay, so we did A, that was this part. So far, B isn't too bad. And now here's part C. All right, little trickier. So if we, basically what I did was this. I want to earn 70 cents. I don't know how many times, and I have to get up to $500. So I'm going to solve an equation. There's probably a formula for this, but I'm just going to use this equation. Okay. And it is, I'm getting 714.28. Now, this is actually a standard. One of the standards is we don't round sample sizes, to where we should. We kick them up to make sure that we're at least. And then that's what this said, at least 500. So if we said 714, we would have missed that standard. We have to say we need to go 715. Let's see, number of times the game must be played is the number of times the game must be played. For the expected value, and so on. So you got to make sure that you answer in context of the question. So make sure you take the time to say that. For the expected value of the charity's contribution to be at least $500. Okay, let's see. So this one, okay. So they actually calculated for 1,000 trials the expected value, which, yeah, that would make sense. There's a way that they got that, but since they're not expecting us to understand that, we'll just leave it. We'll just read what they're giving us. Basically, they want us to fit it to a normal distribution. It is really a good idea to go ahead and draw that for them. Now, they're expecting mechanics on this. The mechanics they're expecting is the standardized test statistic from the formula sheet. So they're going to want the statistic minus the parameter over the standard deviation or the standard error of the statistic. Now, so in this case, it's going to be a z-score. Okay, the statistic is, okay, so here's what I'm going to do. I'm going to put it in x's, and then I'm going to turn it into z's underneath it. So 700 is supposed to be the middle. They want at least 500. That's for your x's. A z-score would put 0 in the center. Okay, now we're going to have 500. That's how many we have to have or more. Parameter 700. And the standard error for this statistic is 92.79, or a z-score of negative 2.15. Negative 2.155. Okay. Now, if you also sketch this, even without the proper number, we're going to at least give you a P for this. This is really incredible knowledge right here. Okay, this is demonstrating a lot of knowledge. Now, from here, we can use our calculator, or we can use the Z table. So if you're on the exam and you don't have access to an Inspire, there is a table that you could learn how to use. Message me if you need help with that. Right? My calculator, when I typed into my calculator, I got the probability that Z is bigger, because you want to go that way, than negative 2.155. I'm getting 0.9844 in my calculator. Oh, I'm off by a little bit. Let me redo that one. I rounded wrong there. Let's do this. So it's menu. Let's see. Probability distribution. I want a normal CDF. Negative 2.155. Make sure you're careful. Use this E. I've used the other one before. It's no good. Give you an error. Oh yeah, close enough. Still 9844. It would have been 9845. Okay. So that's right. That was good. That is it for, let's see, just double checking here. Use the normal distribution, approximate the probability. That's your probability right there. And hopefully that was everything. It was. All right. Thanks so much.